Dimension analysis for physics. Okay, these are some problems you may come across. What is equivalent to 90 kilometers per hour? What is the equivalent of 90 kilometers per hour in meters per second? So we have 90 kilometers per 1 hour is equal to how many meters per second? We gotta convert that. Also, we want to convert it to miles per hour. So let's do that. And so we have to also convert it to miles per hour. So 90 kilometers per 1 hour is equal to how many miles per hour? Okay, firstly, let's do 90 kilometers per hour to meters per second. So 90, write down what you have, 90 kilometers per 1 hour. First, let's work on converting kilometers to meters. All right, so this is called dimension analysis. I'm going to write down the dimensions. How many meters are in 1 kilometer? Well, there are 1,000 meters in 1 kilometer. So I write what I want to cancel in the opposite position because those will divide into each other and make it a 1. So I've got the meters. Now I want to get to seconds. And you say, well, how many seconds are in an hour? I don't know, but I know how many minutes are in an hour, and I want to get rid of the hour, so I write it up here so that these can cancel. So in 1 hour, there are 60 minutes, but I want to get to seconds, so I multiply this by how many seconds are in a minute. Well, I want the minutes to cancel, so I'll write the minutes up here, 1 minute to 60 seconds. So let's see. The hour is up top and down here. Those will cancel. The minute is up here and down here. Those will cancel. So my units are going to be meters per second, which is what I was after. To get my answer, I just multiply all of the numerators together. 90 times 1,000 times 1 times 1 is 90,000 meters. And then in the denominator, 1 times 1 times 60 times 60 is 3,600 seconds. Now, I'm going to use my calculator and divide that out. And when I did that, I get a nice number, 25 meters per second is what that changes to. All right, if I have to convert this to miles per hour, I start with what I know, 90 kilometers over 1 hour. The time is still in hours, so all I got to convert is to miles. You do need to know a conversion factor, and there are several you could probably look up, but here's a nice one. 1.61 kilometers is equal to 1 mile. That's how many kilometers are in a mile. So what I want to do is get rid of the kilometers, so I'm going to put this part in the denominator, 1.61, and the mile part up top. So these cancel, and I'll multiply the numerators, 90 times 1, divided by the denominators multiplied together, 1 times 1.61, and I get 55.9 miles per hour. Okay, here's another quick example. In the following, this is just working with units. In the following, X is in meters, T is in seconds, and V is in meters per second. So, and A is acceleration, it's in meters per second squared. So, X is in meters, T is in seconds, V is in meters per second, A is in meters per second squared. So we don't even have a number, we're just looking at the units. So they want to know what are the units of each combination. So if we have V squared over XA, this is equivalent to meters per second squared divided by a meter times a meter per second squared. That's what A is. So in the numerator we have meters squared per second squared over meter times meter is meter squared per second squared. Well, we can do, this is a complex fraction, so you could say the numerator times the reciprocal of the denominator, which is how you divide fractions. And you're going to get that this is a 1. So the units, when they're a 1, this means that there are no units associated with this expression because it divided out to give us a 1. Let's look at the second one. What if we have the square root of x, which is in meters, divided by acceleration, which is in meters per second squared? Well, this is the same thing. Under the square root, we have meters, m over 1, times the reciprocal, second squared, over meters. The meters will cancel. So basically, we're looking at the square root of s squared, or just s. So the units here are in seconds. The third one, what if we've got 1/2 a, which is meters per second squared, times t squared, or second squared? That's 1/2 meters per second squared times s squared. And if you have anything sitting around, you can always put it over 1. That's free, that's legal. These guys will cancel, so we get 1/2 m. So the units here are going to be in meters. All right, let's see. The last one here is a good one. Maybe I'll just separate this to a second video.